Hello, welcome everybody to channel Sube. Today I am going to discuss question number 50 of 2020 Physics MCQ paper. 5 thin flat metal plates, each of area capital A, are kept parallelly in vacuum with an equal gap symbol D. If plate P is connected to S and plate R is connected to T using conducting wires as shown in the figure, the equivalent capacitance between terminals X and Y is given by. There are 5 answers. Now let us try to solve this problem. So this is a complex network of capacitors, therefore we have to simplify this. So suppose this X terminal is connected to the positive of battery terminal. Since this Q plate has 2 other plates at both sides, left and right, we have to use not the plate, the surfaces, left side surface and right side surface, both we have to take into account. Since think that this is a plate, it has left side surface and right side surface. There are 2 surfaces for one plate. If only it has 2 other plates at both sides, then only we have to consider both surfaces. Plates like this, it has only one other metal plate at its left sides, then we have to consider only that side, the surface of that side. So since this plate has 2 other plates at both sides, so we have to use the left side surface and the right side surface of that metal plate like this. So this is the X terminal. Then front of that left side surface of Q plate, there is another, this P plate. So we draw only one surface because it doesn't have any other plates here front of it. At both sides it doesn't have other plates, only at the right side it has another plate. Therefore we draw only one surface here like that. Then we can draw this Y terminal. Suppose it is connected to the negative of the battery, then it also has 2 other plates at both sides. So therefore we have to draw left and right both surfaces of that plate like this. Now it is okay. Then this plate shown as S, that also has 2 other plates at both sides. Therefore we have to draw 2 surfaces for that single plate, and it is also connected to this P plate, so therefore we connect it like this. Then this final one, T plate has only another plate at its left side. In the right side it has no other plates, therefore we consider only the left side surface, this like this, only one surface, the other surface is not used here. So it is connected to the negative directly, therefore we have to connect it to negative like this. Directly it is connected to negative. So condensers, let us see now what are the condensers. This between these plates there is the electrolyte, so it is a condenser. Here it is a condenser. Here there is a condenser. Then this one also a condenser. But you can't fill these plates because this area is inside the metal plate. Inside a metal plate there are no charges, so therefore it is not a condenser. This one also you can't fill like this regarding as a condenser, because this area is the inside of this plate, this R plate. So in a metal plate, there are no charges not accumulated therefore it is not a condenser. This one also you can't consider as a condenser. Only these areas you can consider as a condenser. Now we have to stretch these wires. Let us start from X terminal here, because we are used to calculate circuits like this, so we are going to convert it to that form, because this is a complicated network. Here and there wires, plates, and difficult to understand. Therefore we start from X here, from left side, that is the positive terminal. So this condenser now we are going to draw. Red plate, left side plate, then front of it the dark green plate, front of it the dark green plate, then it is connected to light green plate, one of the light green plate, like this, the connecting wires like this. So we finished this one, we finished this plate, and this plate also we finished, and this plate is what now we have drawn. Then front of it the purple one, I am going to draw this one, the purple one here. So it is directly connected. So this one I finished, this one also finished. Then it connects to this by this wire to negative directly. So we have to draw this one. This is the negative wire. Using blue color I draw it like that. And now we finished this part, also finished, this part also finished. Then this light green plate has another surface, this left side surface. It is connected directly to this the right side surface. So therefore we have to draw this left side surface. It is connected to right side surface is this one. So those two surfaces are connected like this at this junction. So therefore we have to connect these plates like this. Connect this wire, connect to both surfaces of light green plates, light green surfaces. So front of this light green surface, that means this one, front of it the blue right surface of the blue plate. Now we are going to draw that. Front of it this blue plate, this one. So there is a condenser. It is directly connected to Y wire like this. Then still we have this one, we didn't draw it still. So directly from Y wire, negative wire, and directly from positive wire there is a condenser. This two. Then directly from positive wire like this, directly from negative wire there is a condenser. One surface is drawn using red color like this, and other is drawn using blue color. This is the final circuit. Now you can solve it easily. Suppose capacity is C of each. So these are parallel, easily you can see it, these are parallel. So instead of these two you can draw a single one, CC, 2C, twice C, since they are parallel. So I draw one condenser for that, and I write here 2C because they are parallel. These two are series. If they are series, you know how to solve. How to solve? If they are series, multiplication divided by sum. So 2C times C divided by 2C plus C. Multiplication divided by sum. So when we solve it, simplify it, 2C squared divided by 3C. 2C plus C is 3C. So 1C cancel, 2C divided by 3. That is the resultant capacitance. So this 2 we simplify to this single one. So now we have this one, so it is here. Now series so parallel, they are parallel, so just you have to add 2c divided by 3 plus this c means we can write 3c divided by 3, then c, so 3c divided by 3, then 5c divided by 3. You know c equals epsilon naught divided by d, then we can substitute it here. So final capacitance is 5, instead of c we can write a epsilon naught divided by d, so 3 is here. 5 divided by 3, 5 divided by 3 epsilon naught, 5 divided by 3 epsilon naught d, this is the answer, second one is the answer. So thank you very much guys for watching my videos. If you haven't still subscribed, please do it right now. See you tomorrow. Goodbye.